Buckyballs! Whoa, whoa, whoa! Hold your horses. What the hell are buckyballs?
Buckyball is the informal name for the molecule called buckminsterfullerene. Buckminsterfullerene has the chemical formula C60, which basically means that it has 60 carbon atoms. It's a carbon compound. The extraordinary thing about this molecule is that it looks like a football, doesn't it? Not many molecules in chemistry look like footballs.
Buckminsterfullerene, or buckyball, is one of carbon's 3 million compounds. Wait, what? Yes, you heard me right. Carbon has 3 million compounds.
3 million!
My friend, we've just dived into one of the most interesting topics in chemistry, and in fact, all of science.
So, without wasting our time, let's learn about carbon and its compounds. I know exactly what you're thinking right now. But why carbon? What's special about carbon? Why can't we learn about oxygen and its compounds or uranium and its compounds? Why carbon? Well, many things are special about carbon. Here are the 4 things that make carbon so special. It has more than 3 million compounds, as I just told you. It can do catenation. Whoa, what the hell's catenation? Well, don't you worry, we'll define that for you in a moment. It's tetravalent, which we will also talk about in a second. It's the 4th most abundant element in the Milky Way. Amazing, isn't it? Catenation. Catenation is the ability to be able to make extremely long molecules really quickly and easily, which is something that carbon can do. The tetravalency of carbon. Now, before I talk about this, I'll tell you one fact, that the outermost shell of any atom can hold 8 electrons. Not more than that, but yes, it can hold less than 8 electrons, but not more than 8 electrons. So, a carbon atom has 4 electrons in its outermost shell. That means it has a valency of 4. If it would hold 3 electrons in its outermost shell, then it would have a valency of 3. If it would hold 2, then it would have a valency of 2. So do you get what I mean? Tetra means 4. So it has a valency of 4. Now let's talk about the abundance of carbon. It is the 4th most common element in the universe. And not only that, but 20% of you and me, 20% of the human body, well, almost 20%, is made of carbon. Isn't that fascinating?
Now, let's look at some general information about carbon. I know this can be a bit boring, but
I'll make it more interesting for you.
The atomic number of carbon is 6. The atomic number is the number of protons in one single atom of a specific element. The atomic mass of carbon is 12.011 atomic mass units. The atomic mass of one atom of a specific element is approximately equivalent to the number of protons plus the number of neutrons. Carbon is solid at 20 degrees Celsius. Its key isotopes are carbon-12, carbon-13, and carbon-14. Isotopes are atoms of the same element which differ in the number of neutrons, but not in the number of protons. If you change the number of protons, you're changing the element altogether, and we don't want that. So in carbon-12, there are 6 protons and 6 neutrons. In carbon-13, there are 6 protons and 7 neutrons. In carbon-14, there are 6 protons and 8 neutrons. Some key allotropes of carbon are diamond, charcoal, graphite, and fullerene. Allotropes are substances of the same element which differ on the molecular level. Now let's explore some of the 3 million compounds of carbon one by one. First of all, we have ethane, which has a chemical formula C2H6. It has 2 carbon atoms and 6 hydrogen atoms. Then you have ethene, which has the chemical formula C2H4. It has 2 carbon atoms joined together by a double bond and 4 hydrogen atoms. Then you have ethine, which has the chemical formula C2H2. It has 2 carbon atoms joined together by a triple bond and 2 hydrogen atoms. Then you have propane, which has the chemical formula C3H8. It has 3 carbon atoms and 8 hydrogen atoms with no double or triple bonds. Then you have propene, which has the chemical formula C3H6. It has 3 carbon atoms, of which 2 are joined together by a double bond. Then you have benzene, which is a very special molecule because out of all the molecules we will discuss today, benzene is the only one which forms a ring. It has the chemical formula C6H6. Now let's discuss different types of carbon compounds. First of all, you have alcohols, which have the molecular structure looking like this, as shown on the screen, where R and R with an apostrophe can be any carbon and hydrogen containing constituents. Ketones have a structure as shown on the screen, where R and R with an apostrophe can be a variety of carbon containing constituents. Aldehydes are similar to ketones, but not entirely the same. They have a structure as shown above on the screen, where R can be any carbon and hydrogen containing constituents. I am sure that you will come across these hexagonal looking thingies in chemistry and you will wonder what the hell are they. Now I'll tell you. At the vertex of each of these hexagons is a carbon atom. They haven't written it, but you have to assume that there is. It's a shorthand method. All carbon compounds, when burnt, would release carbon dioxide, water, and heat.
Now that brings us to the end of yet another Science Whiz video. I hope you've not only enjoyed this video, but you've also taken time to appreciate the beautiful element carbon. I mean, because if carbon didn't exist, then I wouldn't exist either, and neither would you, or your mom, or your dad, or your pet dog.
But wait guys, before you stop the video, don't forget to check out our website, which is the Science Whiz, not the Science Shiz, the sciencewhiz.wixsite.com/thesciencewiz. I know it's a very long URL, but guys, I just couldn't change it. Very sorry about that. And thanks for watching. Stay tuned for more videos.